Hello, my name is Gabriel Goldstein with Anidea Engineering, and today I'm going to talk about our AEI FX300 prop controller for the escape game industry. I always notice when people are building props for escape games, they tend to start off with an Arduino and they tend to go to SparkFun and add a bunch of other peripherals to it, shields, prototype boards, and they have to add relays and outputs and lights and inputs. And I noticed that a lot of people struggle with some of the electronic aspects of controlling their props electronically. So I created the AEI FX300. It takes care of a lot of the headaches for you for all the basics ins and outs of a prop controller. First of all, it's Arduino compatible, so it comes in the direct USB, which uses the Arduino Studio. It's the AT Mega 328 for the processor. It has, in various configurations, it has 2 relay outputs and 6 digital outputs, and a bunch of other inputs which are both analog and digital compatible. There's also a built-in hall sensor and some status lights and some other things that I'll go over a little more in detail. Basic overview of some of the electrical specifications it has. It has input voltage that's pretty wide. We can go up to 24 volts with the proper heat sink. The inputs are 0 to 10 volts or analog 0 to 10 volts. You may have noticed that a lot of people struggle with using 5 volts as IO control voltages, and they talk about their inputs that don't react properly or their props false trigger. I've taken some steps here to make sure that your inputs have a wider input range, are ESD protected so that when people touch things they don't get zapped or they don't zap the electronics. There's also pull downs and also capacitance on each input to help limit some of the EMI considerations that some people have pitfalls with when it comes to the electronic design. Also, we come down to the outputs where we have 2 relays that are normally closed, normally open outputs, along with 6 digital outputs. You can see that you can drive 120 volts at 10 amps, and the digital outputs are 500 milliamps. There's also a linear hall sensor for analog input, which is just very handy since everyone likes to use magnets to trigger props. And there it again is the processor. It's based on the Arduino Uno, and it's also compatible with the Adafruit Metro. And if you are a Arduino Studio person, you can add this URL to your configuration library, and I'll show you where to do that later. Real quickly now, I'm going to go through the configurations that we sell the device in. The very first one's called Bare, and as you can see here, it's basically all the surface mount and no through hole. This is our entry-level module. It's great for people who want to do soldering, want to solder their wires in directly, have headers they want to use, or just want something super cheap and don't really care about the headers. So that's our first version. Then we go to a minimum version, which is what I would consider a standard off-the-shelf prop controller. Looking at this one here, we add 1 terminal block, which has 1 relay output, 2 inputs, 1 digital output, and your power connections. Going down a little further, we go to our full configuration, which is everything populated there for you. And those are the configurations of the AEI FX300. So the reason I built the AEI FX300 was because a lot of people struggle with basic electrical engineering principles for controlling inputs and outputs for their Arduino-based prop controller. So what we came up with was a design that had inputs on it that were already filtered, had capacitance on them, and had pull downs. We used 0 to 10 volts or 0 to 12 volt thresholds so that you didn't have low-level 5 volt input digital I/O signals flying around your room, which isn't really a good design. And also we had the hall sensor, we had relay outputs, and we also have current outputs. So what I came up here with was a little demo to illustrate how some of these devices would work and be connected to your prop. And also I have sample code that I'll go through that will show you how it all kind of comes together and how you can test your code, and all this is available on the internet. Starting off with this product, I'll show you what I have wired up to this design. First I have a standard mag lock here, which comes in 12 volts here, and then it goes out to output 0 through my digital outputs here. I have a solenoid here which draws too much current for my digital outputs, draws 1 amp. So I have that come in from 12 volts out to here through my normally open relay to my normally closed relay and back to ground to create that loop. Over here I have my power coming in off my bench supply at 12 volts. You could use any other off-the-shelf power supply for your purposes. And then we have a typical limit switch that you'll find in a lot of props. This is a digital input going to input 0. And then I have a analog potentiometer which is going to input 1. And now I'll go through the code and show you how this all comes together. This is a piece of code which will come as basically it's downloadable through every design. And one thing you'll notice here is if we go to preferences, you will find that URL I mentioned right here, and that will allow you to set the product up as an AEI FX300, and the libraries and all the Arduino stuff will come in and be configured based on that. So looking through the code here, we have all of our relays, our outputs and our inputs, our standard LED and our Hall sensor all predefined for your easy use on the Arduino. There's also a couple of variables presented here that we use later on. The pin configurations are all set up here. And for debugging, if you're not familiar with serial output, very handy for using debugging Arduinos because they don't have step debuggers built into them. And I start the project off here with my puzzle not being solved, and I turn my maglock on. So what I've done here now is I have several little blocks of code that I'm going to use to show you and illustrate the individual I/O pieces of the device, and then I'll bring them all together as a final product. So here, when I say if1 here, it's going to run this little piece of code here. All my other code blocks have an if0 on it. So when I run this here, you're going to watch the relay and the LED trigger. Now that relay is tied to that solenoid. That's pretty annoying, but you can watch the light here and the solenoid here trigger. Real simple routine, and you can see that working there. Next, I'm going to show you this operation of the Hall sensor. Now, as you can see here, the screen is being filled with 516, the number 516. As I take this magnet to this Hall sensor, you'll watch that number change. Go up a bit, go down a bit. This is not a very strong neodymium magnet, but you can see that you have both. As I flip it around, you can make the numbers go up, and you make the numbers go down. So if you position your AEI FX300 within your prop and have a magnet triggering some aspect of it, you save yourself an input, you get nice analog feedback, and you can set thresholds based on the position and the intensity of the magnetic field. Now I'm enabled the potentiometer. Now, there's a few different ways that you can wire potentiometers into this design. I chose a pretty straightforward, easy way to just feed 12 volts into the divider bridge. And you can see here I can go all the way from 1023 to about 814. There are other ways to get more range out of it, but this was a simple way to get position out of the potentiometer. And lastly, we're going to do the digital input. And you can see the string going from 0 to 1 as I actuate the button. So with all that in place, I created a little pseudo prop that has what I consider kind of an annoying factor to it. So when the prop is not solved, it kind of annoys you and prompts you. It can be used as some sort of feedback to help guide the player whether they're doing things right or wrong or whatever. But I wanted to kind of show how all these inputs could work and just give you an example of how some of this code would work. So the first thing is I start off with a puzzle not being solved. So the puzzle's not solved. Then I turn it into annoying mode. And what I'm looking for here is the hall sensor not being placed. When the hall sensor's not placed, it'll make the relay trip back and forth, and it's in the annoying state. And that'll actually make that large solenoid you heard earlier click back and forth. Once that's solved, and it's no longer in the annoying state, we'll look for the puzzle to be solved. So I look for a range on the knob, and then I feed back the knob in the right position. I'm doing this because if I didn't have this feedback, I would have no idea if my code's running right, flowing right, or anything else. And then I look at my switch position. And then if my switch is 1, I turn off the mag lock until the puzzle's solved, and then I wait and I go into this other state down here where the puzzle's not solved, where I wait for the puzzle to reset. And you'll see here, the first thing I did was read all my inputs. So up here, before I do anything, I read these things all at once. This is just a good design practice to kind of do all your inputs at once, so you make sure you're kind of capturing a single state. If I was doing these reads all the way down through and had to read inputs multiple times, I might find myself at race conditions, which is a fancy term for something changed in the middle when I didn't expect it. So I like to read all my inputs at once and then perform my logic in all of them. So here I'm going to go ahead and run this routine. All right. So now, as you can see, we are in the annoying state. Now this could be, like I said, something prompting the user to grab their attention. It could be shocking. It could be a light flashing on and off, whatever. So to take them out of the annoying state, I have to provide a magnetic field here. And you notice that came off. Now this is not suggested to keep a magnet on here, but it's what I have right now in front of me. I should have just taped that shut. So anyway, now we are out of the annoying state. Now, as I turn this knob, oh, the knob is in the right position. So now I know my code has followed all the way down to here. I'm just waiting for the switch to transition right now. So now I have my mag lock. Mag lock is firmly engaged. Flip the switch. Mag lock comes undone. Puzzle's solved. Yay. Now, one tricky part with this is that you have to now change some other state. Otherwise, the gate will become immediately solved again. So now the puzzle is obviously not solved again. The mag lock is in place. Mag lock's in place and not getting undone. And to solve the puzzle again, like I can do this all day long. I can move the switch in the right position. Notice that it's not going to let me get out of the annoying state until this hall sensor is here. So one key thing is when you're developing your puzzles for your logic, is figure out all these different states and how you want these things to flow. Figure out then. Nope, knob is in the right position, and I can residual magnetism. Puzzle solved. There you are. There's your AEI FX300, a perfect device for all your Arduino-based prop needs. You can feel free to reach me at gabrielg@anidea-engineering.com. That's Gabriel, Gabrielg at Anidea, ANIDEA-engineering.com. And thank you very much.